So you did that twice. I'm not going to write x2. That's nice. So you got 6x plus 3. I like that. Minus 2x plus 4. Okay. And then what did you do to get from here to here? What would you call that? Combined like terms. Nice. Let's see. 6x minus 2x is 4x. I like that. And you get 3 plus 4 is? What is 3 plus 4? 7. Nice. So then you subtracted 7. You get 4 with negative 2. So yeah, I agree with that. That's nice. What can you do at the end? What could you do? What's the last thing you can do on a problem? You get an answer. You could... No, you could check your answer. How do you check your answer? Yeah, plug it into the left side. 2 times negative a half plus 1 minus 2 times negative a half minus 2, like that. So that's 3 times negative 2 over 2 plus 1 minus, well, you multiply, it becomes plus, well, minus 2 times negative a half minus 2 times negative 2. What's negative 2 over 2? 1. Negative 1, thank you. Okay, 3 times negative 1 plus 1. And then what's negative 2 times negative a half? Plus what? Plus 1. And then what's this? Negative 2 times negative 2.
4.
What does this become? 0. So that comes out to be 5. So does it check? It sure does. Yay! 2 smiley faces. It does check. Okay, so you did minus 2x and then minus 4. I agree with that. And plus 3. And then what did you do to get from here to here? What's that called? Distribute. Yes. So you end up with 2x and 2. I like that. And then what do you have to do with this 2 right here? Yeah, so 2x minus 4x. I like that. Minus 8 and plus 6. So there's just a lot of terms, right? Clean it up as you go. So let's clean this up. Oh, I see. I see. So this right here, what's negative 8 plus 6? What's negative 8 plus 6? And then if you want to put it on the other side, you're going to add 2 to both sides. So that's where that 2 comes from. Or wait, yeah, it does. Okay, so to get from here to this step, you have to be careful here. So to add, plus 2 was added to both sides. And what else was subtracted from both sides? You see the 2x right there? It moved over there. So what else did they do? Minus 2x from both sides. So that's why the 2 gets over there and the minus 2x. Are you with me, kind of? In sense here? It's fine, it's fine. Well, these 2 cancel, right? And then you get 10 minus 6 is 4 minus 4. So x does equal negative 1. Now you could check this. I'm not going to make you, but you could check it. You can check it. Do people agree with negative 1? No? Who agrees with negative 1? Popular, yeah. You're popular. Did they copy it correctly? So let's just assume it is and move from there, but generally speaking, I would look to make sure you copied it from the book correctly. Because if you copy one number wrong, what happens? Gone. So let's do some distribution. Is there a negative sign out front of this thing? Yeah, let's clean up the inside first. So what's 3 minus 2x? Nope. What's 3x minus 2x? No. I'm asking the question out loud. What is 3x minus 2x? X, thank you. What's negative 1 times 5?
5.
Negative 5. And then you got to distribute. Oh, is this negative sign around the whole thing? Like, for example, this bracket right here. Can someone tell me, this bracket right here, is that supposed to be alone? Or is it matched up?
No, it's 3 for 3.
Oh, so the negative sign all the way over here too? Oh, so that negative sign is multiplying both sides of the equation? Do me a favor, everybody. Please look at 43. I don't have the book in front of me, so I need your help. Thank you very much. Hold on. What are we in? 2 something? 2 1. Thank you. What number is this? 43? 43. So this right here, like that?
Yeah.
There it is. Okay. So now let's try this. Oh, didn't pause that. Okay, so let's clean this up. What did that become? X minus 5, and there's a negative on the outside, equals negative 4 times, what happens to the inside here? What's 3 times 2x?
6x.
3 times negative 4?
Minus 12
minus 3x. Okay, so now we distribute here to get negative x plus 5. Okay, here's the deal, kids. I'm pretty sure all of you can multiply -1 times 5. When it's only one person participating, that's the only person who's going to get a good class performance grade. 20% of your grade is class performance. That will hurt if you don't participate. So on the other side here, what's the one word for what we have to do now? Or we could distribute. What can we do before we distribute? Oh, there's a minus right there. Ah, there you go. Good participation. Excellent. -4 minus. What's in the bracket now? We wanted to see. What's 6x minus 3x? Ah, minus 12. So you get -x plus 5 equals -4 minus plus. Yeah, I'm liking this so far. I'm liking this so far. What do we have to do at this point? What should we clean up? The left or the right? Let's clean up the right. Yeah, good choice. You get 8 minus. What should I add to both sides? Yeah, so you get 2x plus 5 is equal to. So 2x is equal to. Subtract what from both? Oh, 3. So x is equal to 1.5, 3 over 2. I love improper fractions. Love them. Yes, Nate. So, what we get to talk about now, let's just go over what we've talked about so far. First, yeah, we've done those things. Nice. Attendance, poll, homework check. If you didn't do your journal, you have 24 hours to do it or you get a 0. So I think a couple of you didn't do it, so make sure you do. This Thursday, you have a chapter 1 quiz, like a full quiz. It'll be half of this, about 30 minutes, I think is what I'm aiming for. And then the next day, you'll have a little short quiz on 2.1 and 2.3. So what we get to talk about now are applications of linear equations. And by applications, what I really mean are we're going to be working with word problems. So what we have to do with word problems is first understand how to go from words to actual algebra. First of all, there's addition. That can be through addition, the word sum, more than, plus, added to, increased by, the sum of two numbers. Subtraction, lots of different ways to say subtraction. Less than, less, decreased by, subtracted from, the difference between. Multiplication, times of, as much as, twice, 3 times. Division, the quotient or divided by or ratio. There's really only 2 cases where it gets a little tricky, where order does matter. Here's one of them. 2 less than a number is x minus 2, not 2 minus x. Why might someone write 2 minus x instead of x minus 2 when they say 2 less than a number? Yeah. In the sentence, right? Exactly, right. You're cruising along. You do 2, it's not. What's the relationship? Please put your surfaces flat on the desk. What's the relationship between x minus 2 and 2 minus x? What's the relationship between the two? They're opposites, yeah. 5 minus 2 is 2 minus 5 is? They're opposites, right? So if you flip them, it's not really going to be helpful. Also, a number divided by 13, 13 is in the denominator. Just be careful. Be careful when you set these up. So I'd like to start off by just giving you one question and see what you do with it. So you're going to do this question right here. I'll just set up an algebraic expression to do this, answer this question. So she did length is equal to, what is cm right there? Oh, the length is 1 centimeter greater than 2 times the width. Yeah, exactly, right. Very good. And she got perimeters 110. Excellent. Nice. And what is perimeter equal to? So let's set this up. There's one little thing you could put in here to make it a little clearer, but I really like what I see so far. I really do like what I see. What is it, B period right now? Here we go. So she wrote length is equal to 1 centimeter plus 2 times the width. That's great. That's a great start. I really like that. And then she wrote the perimeter is 110, but what is perimeter equal to? 2 times the length plus the width. 2 times 2L plus 2W. So then I think you distributed, so you got 2L plus 2W is the perimeter. But what is the perimeter equal to? What is the perimeter? It tells you 110. So you know 2L plus 2W is 110. But what do you know L equals? What do you know L equals? Look at the first line.
1 plus 2W.
L is equal to 1 plus 2W. So where can you put that, Nate? Put it in for the L. So this kind of remember substitution-ish, something like that. 2 times, oh, I don't want to use the highlighter for this. It's kind of annoying. 2 times, what is it? 1 plus 2W plus 2W equals what? I'm plugging in for L. So yeah, you have to.
No, it's not 2W.
L is equal to 1 plus 2W. You wrote it right there.
No, the second part.
This is L, right?
Yeah, and that's...
This is the 2W from there. Right?
Oh.
Is that right, everybody? I think that's good. A little differently. There's many different ways, but is my algebra correct? So L, look where L went, everybody. L was there, and then we substituted it in right here. But what is L equal to? This right there. So now what can I write? I'll change color. Now what is this called? What am I doing? Distributing. I just substituted, yep. Plus 4W plus 2W is equal to? What can I clean up? How do I clean up the left side? What? Add them together, yeah. 2 plus 6W is equal to 110. So 6W is equal to? So W is equal to, I did 118 in the last class. I subtracted it. They didn't like it. They got all angry at me. What's it equal to? 18. You're not done yet because it asks you for the length as well. If you want to get the length, you know L is equal to what? 2 times W plus 1. So that's 2 times 18 plus 1. So it's equal to 37. So you think L is equal to 37 and width is equal to?
18.
How do you check this if you wanted to check it? Let's check it. There's two things that have to be true. The perimeter is 2 times 37 plus 2 times 18.
Yeah.
What's 2 times 37?
74.
Plus 36, and that does equal. So is that one check? Yay, we're happy. Nice. But what's the second thing we have to check? L is equal to 2 times 18 plus 1, which is indeed 37. 2 times the length plus 1 should equal the 2 times the width plus 1 should equal the length. Is that true? So did it check? Yes. Nice. Good job. Good job, kids. Good job. The work is very important. So what did we do to do this? Well, the first thing we did was we read the problem several times if necessary. Make sure you understand it. A really common way to make your life harder is to miswrite it down, make a mistake. Assign a variable to represent the unknown value. What you don't know, pick a name for, pick a good one, write an equation, solve it, and then state the answer. What could step 6 be? What could step 6 be? We just kind of did step 6. Check. It's a really good idea to check, or at least realize, it's a really good idea to check, and it's still stuck on the highlighter. It's a really good idea to check, because you want to make sure your answer makes sense at a minimum. If you're solving a question which tells you how much a pizza should cost, and all of a sudden it costs $6 million, there's probably something wrong. Yeah, literally, I'll get, a train is going from Cincinnati to Ohio. I'll give a bunch of questions and a bunch of information in a pre-calculus class and ask them how fast the train is going, and someone will get an answer like 16 trillion miles an hour. I'm like, well, I guess I could design a problem like that, but that would be a problem because I think 16 trillion miles an hour is faster than the speed of light, and then you run into relativity problems. Matter suddenly turns into energy, and the world ends. It's a challenging position to be in. So here is the next question I would like you to do. It's right here. I'll leave the steps right on the board for you and everything. How did you do that one? Like, what did you set up to do this one?
I just divided it.
No. I want algebra. I don't want no, because you'll get zeros, and then future will be bleak. No. Yeah, go ahead.
I did V Verlander equals 530 divided by 2 plus 8.
No, don't do it all at once. I don't want it all at once. Why don't you break it down from what you know? What does it tell you? It tells you that Verlander had 8 more strikeouts than Lincecum, right? So V equals L plus 8. And what is V plus L equal to?
530.
There's your 2 equations right there. So if this is true, where can you put that?
In where?
Yeah, where V is. So this right here can go, where can that go? Right there. So if we actually put that in, what do you get? L plus 8 is V plus L is equal to 530. You're not always going to be able to just do kind of the algebra all in your head. It's sometimes going to get really hard, and you're going to not be able to go anywhere except in proper places. So what do you get? You get 2L plus 8 is equal to 530. So 2L. Where's the 2? There's an L right there and an L right there. So how many L's do I have? So I get 522. So what does L equal? 261. And you know that V is equal to L plus 8. So V is equal to 269. There you go. One thing that's great, just to make sure it makes sense, literally say it out loud in your head. Say it out loud in your head. Lincecum had 261 strikeouts and Verlander had 269. That makes sense. You can also check, add them together. Do they work? Yes, they do. Okay, one more here. One more to. Okay, so those are the expenditures in 1990, and what do the expenditures in 1990 grow into? No, that's how much they grow by. What do they grow into? 2,000 billion, right? $2,000 billion. So you have X, and something happens to it, and it turns into 200 billion. What happens to it? Tell me in words. What happens to it? It increases by how much?
180.
Increases by 180%. What do you multiply something by? If you increase something by 100%, what happens to it? It doubles. What do you multiply something to double it? 2. If something increases by 50%, what do you multiply it by? No, that halves it. Again, if something increases by 100%, what do you multiply it by? If something increases by 50%, what do you multiply it by? By what? 1.5. 1.5. If something grows by 50%, you multiply it by 1.5. So if something grows by 180%, what do you multiply it by? Okay, let's try it again. If something grows by 100%, what do you multiply it by? If something grows by 180%, what do you multiply it by? You asked, because I would hate for you to go home and then subtract 1 from everything. If you grow by 180%, what do you multiply by to grow by 180%?
2.8.
Yeah.
It's 1.8.
Yeah, so 2.8 equals 2,000 billion. So what do you have to, if you want to solve for X, what do you do? Yeah, you divide. So you get X is equal to 2,000 divided by equals what?
714.2.
What is it? Go to 3.
0.285.
285. So that means $714 if it grows by 180%. If it grows by 180%.
Is this true?
Does it? We'll multiply 714 by 2.8 and test it.